we can finally measure how fast our racing cars are actually going. But measuring acceleration is even more interesting. Our new Arduino project, that we call Speedo, has to go to the racetrack today. However, the principle is applicable to measure any moving object. In the beginning, our idea was to use 3 sensors to measure not only speed, but also acceleration. We explained the mathematics and the interrupt routine, which is capable to measure time intervals to a millionth of a second. A few tests with a cardboard prototype were promising, which is why we designed a 3D printed housing with precise dimensions and some interesting details for it. You are welcome to watch the previous Speedo videos on Electronics Unmasked, and we are of course happy about likes and new subscribers. Today we want to measure the speed and the acceleration of our slot cars at certain points of our model racetrack. We put the Speedo next to the track where we can safely test maximum speed. I'm powering the device via USB from my 10,000 mAh power bank, which is sufficient for more than 24 hours operation. For data transfer between Speedo and the PC, we are using Bluetooth in both directions. A secure connection using a password is an important requirement for me, and I was able to implement that on my ESP32 development board. I will talk about the details of that features in a separate video. On the PC, I'm using the terminal program CoolTerm to send commands, receive the data and save it to a file. CoolTerm supports my Bluetooth connection, just as well as a serial USB connection via cable. We can send commands to configure Speedo, and the device is sending its measured data. While logging the data, I see remarkable speeds and accelerations, considering we are using standard Carrera 24 slot cars. We are measuring the maximum speed, the acceleration from standstill, and the acceleration from lower speed. When the slot cars are braking, Speedo is measuring indeed negative acceleration values. Our idea is now to compare different slot car models in top speed and acceleration. Cool, isn't it? And we are curious to see the effects of different gears, motors, aerodynamics, magnets, etc. Even comparisons between drivers at critical points along the track are possible. We are operating our racetrack at 18 volts using a lap power supply. On a few vehicles we modified the motors and gear ratios to increase the performance a bit. Magnets at the bottom of the chassis are adding downforce besides the aerodynamics. As a result, our slot cars are achieving more than 3G for both acceleration and braking. Without additional downforce, you cannot achieve significantly more than 1G. You can derive that from physical law that applies to real racing vehicles as well as to slot cars. In top slot car competitions, significantly higher speeds and accelerations are achieved, and on that we are making an interesting comparison in a minute. Given our means and skills, we can't keep up with the top class. We're just amateurs who enjoy crafting and racing. Anyway, it's a lot of fun for us. Now that we know the maximum acceleration of our slot cars, we can do some interesting calculations to classify this. For the following, we are always considering a standing start. The initial speed v0 is 0. The green values in the table are showing us the distance traveled in short time intervals at different accelerations, which we plotted here in the left column. In the bottom tables we have calculated the corresponding speeds in meters per second and in kilometers per hour. For comparison, we can look up what a really fast road-legal sports car can achieve. Provided good grip and insane power, it could reach 1.5 G and thus accelerate from 0 to 100 km per hour in around 2 seconds. In fact, you can find expensive sports cars where they claim they can achieve this. The distances covered in that table are of course too long for our racetrack. So we go to tenths of a second intervals. The distances covered in the time intervals are still significant. After 0.3 seconds, the vehicles are almost at top speed from a standstill, and then they are covering a considerable part of our track length in every tenth of a second. I think if you want to be a good slot car pilot, your reaction time has to be significantly better than a tenth of a second. Up to here we were still talking about our home toy slot cars. Now let's have a comparison with the super slot car class. To do this, however, we have to increase the range for the acceleration. Searching the internet, I found that super slot cars accelerate from 0 to 100 km per hour in 0.3 seconds. That is absolutely insane. According to our table below, this corresponds to an acceleration of approximately 10 G. These vehicles are covering 4 to 5 meters within no time. I almost can't imagine how quickly you have to react to drive such a fast vehicle optimally. Chapeau! That's really incredible what these pilots are delivering. Back to our measuring device. We put quite some thought into the design of the casing and the code to get well-defined trigger points for the infrared sensors. Speedo actually works pretty well indeed. However, you need to pay attention to the following to make it work reliably. The cars should drive close to the sensors. 2 centimeters is a good distance here. The vehicles need to reflect the infrared radiation well, so that the sensors are getting an exact trigger point. Sticking a small piece of aluminum foil to a racing car helps, in case it doesn't reflect infrared radiation well. And you should avoid distracting light. Adjusting the sensor's sensitivity to the slot car's distance yields the best measurement results. Now I want to give you 2 ideas for further improvements. Sensors that are using laser diodes can be more accurate over a bigger distance. In case you don't need flexibility, you can put the sensors under the track with the slot in between, as one of our followers suggested. We actually did it. Our Speedo not only measures the speed, but also the acceleration of our slot cars. The maximum acceleration measured was around 3 G, and the top speed was over 20 km per hour, corresponding to more than 480 km per hour in original size. Our racetrack, which we pimped with our DIY lap counter and the Speedo, has become a pretty cool toy. What do you think? Write me in the comments. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.